Saxon Algebra 1, Lesson 14. In this lesson, we study evaluation of algebraic expressions. In Lesson 4, we learned about the difference between a number and a numeral. A number is an idea. A numeral is a symbol for a number. For example, each of the following is a numeral or numerical expression for the number 7. That's the one we're most familiar with. That's 14 divided by 2. That gives 7, of course. 4 plus 3 is 7. Negative 21 over negative 3 is positive 7, because when you divide two negatives, you get a positive. Each of these represents the number 7. 9 plus 5 over 2. You do the numerator first and then divide by 2. We say that the value of each of these expressions is 7. In algebra, we often use letters to represent numbers. When the letters as well as numbers are used in an expression, we call it an algebraic expression as opposed to a numerical expression, or sometimes just an expression. The algebraic expression 4 plus x has a value that depends on the number we assign to x. For example, if we assign x to be 5, then 4 plus x is 4 plus x. That's 4 plus 5. And so it's equal to 9. If instead we give x the value 11, then 4 plus x is 4 plus 11, and that's 15. Because the value assigned to x can be changed or varied, we call letters such as x variables. We also call letters unknowns, since they represent unknown or unspecified numbers. The numeral 4 in the previous example did not change when we use different values of x, so it is called a constant. That is, a constant is a representation of a number that never changes. When we use variables in algebraic expressions, the notations that we use to indicate the operations of division and algebraic addition are the same as those we used in numerical expressions. The notation for the multiplication of variables can be the same, but more often we do not place anything between the constant and variables being multiplied. For example, 12xy has the same meaning as 12.x.y or 12 parentheses x parentheses y. So 12xy means 12 times x times y. Remember this: when there is no operation between a constant and a variable, or between two variables, then their values are to be multiplied. For example, xyz means x times y times z. 27a means 27 times a. 5x plus 6y means 5 times x plus 6 times y. When a variable appears more than once in an expression, then that variable represents the same number everywhere it occurs. For example, if x equals 5 and y equals 4, then the expression 2xy plus 3x is equal to 2 times 5 times 4 plus 3 times 5, which is 40 plus 15, or 55. Here are some problems. First one, find the value of xmp if x is 4, m is 5, and p is 2. Well, xmp means x times m times p. And so if we put the numbers in, we have 4 times 5 times 2. And so we have 20 times 2, 4 times 5 is 20, which is 40. Number 2, evaluate 4ab minus 5a if a is 2 and b is 3. Well, 4ab minus 5a means 4 times a times b minus 5 times b. Now we put 2 in place of a, and 3 in place of b, and then we've got another b, so we put another 3 in place of it, and what we end up with is 4 times 2 times 3 minus 5 times 3. So we do the multiplication parts first, and we get 24 for 4 times 2 times 3, and 15 for 5 times 3, so this is 24 minus 15, which is equal to 9. Number 3, bunch of minus signs. Evaluate negative p minus parentheses p minus q if p is negative 4 and q is 5. Do you see any multiplication in this problem? I don't. If p is negative 4, then the minus p, I almost said negative p, that's not correct, it's the opposite of p, is positive 4. Do you see that? If p is negative 4, then the opposite of p is positive 4. So when we put the variables in, we'll put positive 4 in place of minus p. And then we put the negative 4 in place of the p, and we put the 5 in place of the q. So we're doing a little trick to make the problem simpler. Since we see opposite of p in the expression, we translated that to mean positive 4, since p is negative 4. And so here's what we have left, 4 minus parentheses negative 4 minus 5. Well, we have to do the parentheses first. Negative 4 minus 5 is negative 9, so we have 4 minus negative 9. And that's 4 plus the opposite of negative 9, in other words, 4 plus 9, which is equal to 13. Number 5, evaluate minus x minus a plus b. What is that minus x? It's the opposite of x there, and we have the opposite of a there. And it says if x is 2, a is negative 4, and b is negative 6. Well, let's see. Because of all the negatives and opposites, we will first replace each variable with brackets. There, see, I put brackets in place of x and a and b. Now we place the values of the variables in their respective brackets. Okay, we put 2 in place of x, and we put negative 4 in place of a, and we put negative 6 in place of b. Okay, so let's see what this is. This is negative 2 minus parentheses, the opposite of negative 4 there is positive 4, and we have plus negative 6, which is the same as saying minus 6. And so that's negative 2 plus the opposite of negative 2. See, 4 minus 6 is negative 2. That's 4 plus negative 6. We could have left it that way. 4 plus the negative 2 plus the opposite of negative 2. That gives us negative 2 plus 2. And they cancel each other out. So that's 0. Number 6, evaluate opposite of m plus x times parentheses opposite of a plus mx. If m is 2, x is negative 3, and a is negative 4. We've got opposites and negatives. Looks a little confusing. So again, we will replace each variable with brackets and then fill in the values. So putting the brackets there, now we want to put 2 in place of m. M occurs in 2 places. And we want to put negative 3 in place of x. That also occurs in 2 places. And then negative 4 in place of a. So this is what it looks like. Now let's see what we can do with that. I see the opposite of negative 4 in the second set of parentheses there. So we can rewrite this as the opposite of parentheses 2 plus negative 3 times parentheses positive 4 plus negative 6. You see the negative 6 is because we've got 2 times negative 3 at the end there. And then we work out those parentheses, and we have the opposite of negative 1 times negative 2. Well, negative 1 times negative 2 is positive 2, so we have the opposite of 2, which is negative 2. Well, that's the end of Lesson 14. Your assignment is problem set 14 on pages 65 through 67 of your book.